So, ladies and gentlemen, I'm pleased to see that somebody has come today. My name is Anna, and today I have the honor to present you a robotic machine that fulfills all criteria for the daily usage at school. So, first of all, can you imagine our young generation without a computer, a laptop, or with their smartphone? We would be hopelessly dumped. But many of these young people don't even think about all the work that is behind their magic little toys. And if the next generation loses this art, we will only be submissive slaves of our own digital gadgets. Despite that, there is a critical loss of enthusiasm and motivation notable, as you can also see in this diagram. Therefore, we would like to motivate more people to be interested in computer science. And our solution we will present in this talk today. So, isn't computer science not more than just a green number on a black screen? We think it's even easier to understand everything you have observed and touched. So if we can also make programming touchable, game-based and authentic, learning can be realized easily. And therefore, we believe that the obvious solution for school is using robots at school. Then robots are inspiring and motivating by making theoretical calculations even more physical. Hence, robots belong into school. Of course, there are already robots in school, but often one robot must be enough for a considerable group of students. And it's proven that the learning effect can be obstructed by the oppression of a team. Therefore, our main goal is one student, one robot. But what do you think a perfect school robot requires? We decide that a perfect school robot has to fulfill 3 criteria: low price, small size, and connectivity. So, schools often running out of money. Let's see what the most efficient school robots on the market cost. And we start with the Kilobot. This robot was directly designed to investigate the behaviors of 1,000 of robots. But later on it was also introduced as an educational robot. And when you buy 10 of them already assembled ones, one of this robot already costs $148. And this is already way too expensive for schools. But the real problem is the hardware to program this robot. Then the so-called overhead controller costs $708, and I think it's clear this is too expensive for every school, and no school can provide a single robot for every student. So the other robot is the AE robot, and this is the successor of the Kilobot. And it only costs $32, so it's much less than the Kilobot, but I think it's still too expensive for schools. Also, we have the obstacle avoiding robot, and this is an Arduino-based educational robot, and you can already buy this kit from this robot for $80. So, as you can see, there are already some quite affordable robots on the market. But last year we also created our own robot directly designed to make learning, programming easily. And as a condition, we set ourselves that this robot has to cost less than $10. So we derived the name from the Greek word Dezi, what means 10. And here you can see our robot, the Dezibot. And this robot only costs $8.59. So many people make fun of me because of my small size of 5'1" and call me a small dwarf. I always say you have to reduce to the breast, and it's the same with educational robots. Why we have to pay the attention of the size, you may ask yourself, and it's really easy. In school there are only a limited space for every student to work on. An ordinary school desk is not so big, and there are no dedicated rooms to operate the robots. So that every student can have their own robot, the robot has to fit on an ordinary school desk. So let's go back to our robots from the last category and starting with the obstacle avoiding robot. With a size of half a square foot and as well as kinematics, it's way too big to fit on an ordinary school desk. The AE robot uses vibration motors as kinematics, and that's also the reason why this robot is with a size of 2.4 inches in diameter, rather small and can fit in an ordinary school desk. Also, our old version of the Dezibot used vibration motors as kinematics, as you can see here. And so with a size of 1.58 inches in diameter, it's smaller than the AE robot and you can use it on an ordinary school desk. And the kilobot also uses vibration motors, as you see here, and it only has a size of 1.3 inches in diameter. So within the last year, we also worked on a successor of the Dezibot. And this robot, you can see here, it's the Dezibot2. And I can also give you one of these robots now, so you can look at it better. So, because of adding a lot of cool new features to this robot, we get a little bit bigger in size, and now we have a diameter of 2 inches. But as you can see, we are still one of the smallest educational robots. So, next up we look at the connectivity. The connectivity is a really important aspect since it has a great influence on efficiency, teamwork, and motivation. Within the digitization of our society follows also a change of our teaching methods. So, to create intensive and also interesting lessons today, it would be useful if you can show live data and measure values of the robot live in class. Also, it would be really cool when you can upload the program to all robots in the class, and so can students see the impact of amendments to a program on their own robot. So, let's see if our favorites from the last category turn those ideas into reality. Our old version of the Dezibot, the obstacle avoiding robot, and the RER robot all use wire-based communication, and yeah, that doesn't allow bulk upload, and also you don't can visualize something in class. The kilobot uses this overhead controller for upload the program to the robot, and so the overhead controller sends IR signals to all robots in a range of 1 meter. That's really cool, but the communication only works in one direction, and also the opportunity of putting a single robot in a group can't be realized anymore. So, as you can see, no robot really aces this category. We thought about this for a while, and see, when my grandpa was a student, and you would have asked him what he can neither see nor feel, but still need to live, he would answer with air. And when you ask the same question to a student of today, the answer would be Wi-Fi. So we got the idea to create a robot that can communicate via Wi-Fi. And here you can see the robot, the Dezibot2. We designed the Dezibot2 completely on our own, and thereby our main focus was on reducing the electronic components so that we have a small, easy, and inexpensive robot. The design from the Dezibot2 was inspired by the kilobot, but we added a lot of cool new features you will see now. First of all, we decided the microprocessor should be an Arduino one, because Arduino allows easy debugging and step-by-step learning for beginners because of libraries, tutorials, an IDE, and a large community. Also, it's really useful that Arduino is compatible with various operating systems just like Windows, Linux, and macOS. Then, as you maybe know, every school has different technical equipment, and as you probably can imagine, no school is really interested in a robot that isn't compatible with their own digital gadgets in school. So we looked for the most inexpensive and efficient Arduino boards, and yeah, no other board convinced us like the Remus D1 Mini, since it has an ESP8266 piggyback style on it. This is one of the most important IoT boards, and it has 15 KB RAM and 4 MB flash memory and already integrated Wi-Fi. Also, the memory is no limitation anymore, and this board will be supported by a huge number of libraries. So this is the most powerful board available at this class of price and size. And yeah, so we picked this removable mini piggyback style on our robot, as you can see here. Now, you can upload the program to our robot by using USB wire. Of course, it's an Arduino board, but even cooler and more revolutionary is to upload the program to this robot by using Wi-Fi. So, next to this, we also have two vibration motors, and therefore we cleared out the bottom of the PCB, as you can see here, so that we can use more powerful vibration motors. Now, you are maybe wondering, how can this work? How is the robot supposed to move around? And it's really easy because next to these vibration motors, we also have 3 rigid legs, and so the robot is a sliding arm. Next to it, we also have 3 IR sensors and transmitter. As you can see here. And so the robot can detect each other, can detect the distance of each other and the direction of other robots. So also we have a daylight sensor, as you can see here, and so the robot can perform phototaxis. Also debugging is really easy because of an RGB LED. It's really difficult to see them here, but you have the real robot in your hands, so you already see them. And of course we also have a battery cell, and this battery cell provides the robot with power for approximately 1 hour, and it's also really easy to charge the battery because you only have to connect the robot by USB wire to a computer. So our main focus was that the robot can be used as a web server, so you can visualize internal variables and measure values on a computer, a mobile phone, or also on a projector in class. That's already really cool, but something really amazing is that you don't need an additional access point because every robot can work as such. Despite that, our robot can build up a telnet server by using common prompt, so every student can log into it really easily. And so you can control the movement of the robot, send and scan IR signals, and also control the RGB LED. So, to conclude, our robot has low as well as high complexity programming, perform phototaxis, and can implement swarm algorithm by using IR signals. Also, it allows visualization and interactivity in class. But rather than talk about it some more, let me show it to you. So first of all, I would like to present you the ad hoc mesh network. So no, you don't see it. Wait a second. So now. So I have to connect this with the computer. Yeah. So we build up an ad hoc network, and these 2 robots are not in this network, and also we have an additional node in this network, and these are 2 Arduino boards, which works as an HYD interface. And now you can see the received data from the robot on the projector, and I can explain it to you. So here you see the number of the robot, and then here are the sensor data. So these are IR sensor data, and this is the daylight sensor. And normally when we have sun in this room, I can show you that the IR sensor will decrease when I hold my hands over them, but we don't have sunlight here, so I can demonstrate it now. So next I also would like to show you the so-called find a friend mode from our robots, and it's a little bit more difficult because the robots are really small, so I don't think that you see them when they move around here, but maybe you already see them in the poster session the days before, or you come to the poster session after this presentation because then we will also show it to you. But I will demonstrate it to you because you can see it a little bit because of the light. So we have 2 robots again, and this robot sends an IR signal, and this robot will detect it. I hope everybody see the RGB LED. So now the robot don't see the other robot because the RGB LED is blue. And when they see each other, the RGB LED turns to orange and to green, sorry. And when it turns to orange, the robot will move in this direction. So now it's orange and normally they will roll forward now. But you don't see it because I hold them in my hands. So, of course, we are not 100% finished yet. Next, we plan to implement bulk upload, and also we have the idea of a so-called exit route. Therefore, we think that a teacher can upload an empty program to all robots in class so that no student can use a home pre-written program during tests or exams. Last but not least, we also would like to design a curriculum for schools after trying out the Dezibot in real class situation. And to make our robot even more attractive for schools, we will build up a community and also would like to create tutorials for students. So, our robot allows interactivity and visualization in classes, and no other robot is so easy to handle, provides comparable features and supports such convenient methods of software development. So, what do you think this small, innovative and Wi-Fi based robot costs? Any idea? Well, this robot only costs unbelievable $7.33. And by this is the most inexpensive robot out of all robots mentioned today. So, hence, we can achieve our main goal that every student can have their own robot by providing a really reduced and low-cost robot. Also, the robot is really small, so you can use them nearly everywhere, even on a school desk, and its connectivity makes it possible for new and cool teaching and learning methods. So, let me conclude one more what is important. One student, one robot, low price, small size, and connectivity. And this is exactly what you've got here. And yeah, we believe that this is the first revolutionary step in utilizing robots in school. Thank you very much for your attention. If you have any questions, I will be really happy to answer them now. Yes?
Have you guys received funding to build these, or are you guys just working as this is an independent project that you started, so you purchased all the parts, manufactured, program?
So we are all in high schools and we meet each other in an extra lesson, I would say like this. So we go to university for, I think the first time we go to university was 3 years ago already, because now we are in class 11 and it starts in class 8. And then we meet each other and then we get the idea of work together, and last year we started working together on this project, and now we always go to university after school, and so there we build up this project and create a robot.
So, but you guys are the ones that you're physically putting all the pieces together? Yes.
We designed them completely and put all the pieces together. We make everything in our group.
Okay.
Yes?
So do you have a problem with noise? I mean, it seems like a room with 30 students with these dancing around on the table would be kind of loud.
They are not so loud. I can show it a little bit, but they don't work on this, I think. Okay, you don't hear it now. They are not so loud, so we not test it with 30 students, but we will test it in future time before we bring them to schools. But they are so small, they shouldn't be so loud. Yes?
So, what programming languages?
We use Arduino and we program this robot in C++. Because in our school this is the most popular language, and we think it's also popular in informatics in generally. And so we think it's really useful when students can speak this language. Yes?
You all said that you all are going to be building tutorials. Have you all started, or is this like truly future? Do you all have any tutorials out there?
No, so we already started a YouTube channel, but we don't upload any tutorials till today. We only have an other presentation from our first publication there, but we don't have tutorials online in this moment.
Are you going to make them, are you going to, like, how are you going to distribute the robots? Are you going to, like, give the design, you're going to put it online for purchase, or are you actually going to put them together and distribute them, or?
So we are not 100% sure. In the first moment, we really think that you could only buy the design and then you can solder it on yourself. But then we did in the United States, it's not so that you don't soldering in school in the United States. So we think, okay, you have to buy it completely built and only learn to program. But yeah, maybe when somebody would like to soldering them on themselves, they also can do it. But now we think it's better when the students only learn to program with them. But yeah, we're not so 100% sure. Yes.
Do you guys have a patent on this? I mean, you're doing research and you're publishing, you don't want anybody to take away from your idea. Is that like a plan? Have you guys started on that?
And no, we don't have a pen on it. We have nothing on it. We wrote 2 publications, but that's all.
All right, any other questions?